At Saturn's North Pole, something impossible has been spinning for decades. A storm perfectly shaped like a hexagon, larger than Earth and sharper than any natural formation we've ever seen. And after 40 years, it hasn't faded, moved, or lost its shape. When most people think of Saturn, they picture its rings. But what almost everyone forgets is that this planet hides something far more mysterious. Beyond those golden rings, at the very top of the planet, lies a storm that doesn't behave like anything else we've ever seen. It was spotted in the early 1980s by Voyager, and at first, scientists thought it was just another swirling cloud pattern, until they looked closer. What they found was a storm shaped with edges, 6 of them, forming a perfect hexagon locked around the planet's north pole. This storm has stayed in the exact same place for decades, rotating with the planet like a solid structure. What's even stranger is that Saturn has no solid surface to anchor anything. It's a planet made of hydrogen, helium, and high winds. So how does a storm in a sea of gas stay this precise for more than 40 years? To even begin answering that, we have to look deeper into Saturn's atmosphere. Near the North Pole, winds race at more than 300 kilometers per hour, swirling through bands of gas that move at slightly different speeds. That's where things get interesting. Those tiny differences between fast outer winds and slower ones closer to the pole can create waves that fold and twist the air into complex shapes. On Earth, that kind of instability would tear storms apart. But on Saturn, the conditions are so vast and consistent that those waves stabilize. When Voyager first caught it on camera, scientists assumed it was temporary, maybe something that would vanish within years. But then, 2 decades later, Cassini arrived. It captured the same formation, same size, same sharp angles, still spinning as if frozen in time. What Cassini found wasn't just a storm, but a jet stream, a 6-sided current of gas rotating perfectly around the North Pole. Each side of the hexagon stretches over 14,000 kilometers, larger than Earth itself. And yet, the entire structure spins in perfect synchronization with Saturn's rotation, completing one turn roughly every 10.5 hours. To test this, scientists recreated the effect on Earth using rotating tanks of fluid. When they spun the liquid at just the right speeds, wave patterns began to appear. And sometimes, those patterns stabilized into hexagons. It was proof that Saturn's storm could form naturally, driven purely by fluid dynamics. But even that didn't solve the mystery, because while lab-made hexagons quickly collapse, Saturn's has remained stable for decades. Something deeper must be keeping it in shape. Perhaps it's a hidden jet stream beneath the clouds, or heat rising from Saturn's metallic core that fuels a steady upward flow of energy. Whatever it is, it's unlike anything else we've seen in the solar system. Over the years, scientists noticed something else that made the hexagon even stranger: its color changes. When Cassini arrived in the early 2000s, the storm looked pale blue, surrounded by faint shadows from the planet's long winter. But as Saturn's seasons shifted, the blue started to fade. By the time the planet moved towards summer, the hexagon had turned golden like the rest of the upper atmosphere. At first, people thought it was just the angle of sunlight, but that didn't explain everything. The change went deeper than lighting. Saturn's atmosphere itself was reacting to the shift in seasons. The planet takes nearly 30 Earth years to orbit the Sun, so each of its seasons lasts more than 7 years. During that time, sunlight breaks apart methane and other gases in the atmosphere, forming new compounds that scatter light differently. And the result is a slow, planet-wide color shift that the hexagon sits right in the middle of. So why a hexagon? Why not a circle or an oval like every other storm we've ever seen? The answer lies in the way Saturn's atmosphere moves. Unlike Earth, where storms twist around solid surfaces and coastlines, Saturn's weather is driven entirely by jet streams, powerful bands of wind that race endlessly around the planet. At the North Pole, one of those jet streams wraps tightly around a central vortex, but instead of staying smooth, it begins to oscillate, creating waves that bounce around the pole again and again. Those waves naturally settle into a 6-sided shape, the most stable pattern possible for that flow. What's fascinating is how unique that is. Comparing it to Jupiter, for example, storms like the Great Red Spot spin chaotically, shifting and shrinking over time. They're massive, but unstable. Earth's hurricanes behave the same way, always changing, breaking apart, or merging into new systems. But Saturn's hexagon endures. We only began to understand the hexagon's true nature when Cassini arrived at Saturn in 2004. For more than a decade, it orbited the planet, watching that storm from every angle through visible light, infrared, and even ultraviolet. Cassini showed details no one had ever seen: towering clouds moving in layers, and a massive vortex sitting perfectly in the center of the hexagon, like an eye. This also led to one question: how long has the hexagon actually been there? Voyager first spotted it in the early 1980s, but the data suggests it could be much older. Some astronomers think it's been spinning for centuries, maybe even since Saturn's atmosphere first settled into its current state. If that's true, it means this storm has outlasted generations of technology, entire space programs, maybe even all of modern astronomy itself. What's strange is that it doesn't show signs of fading. The winds that shape it haven't slowed, and the pattern remains locked in place, even as Saturn's seasons shift and the light around its pole changes. For all we know, that same six-sided storm could keep turning long after we're gone. If you enjoyed this breakdown, consider subscribing, and you might want to check out my other videos.